In this tutorial, we will show you how to connect to an InoDrive target device and make a simple program to run a motor. We will start by opening the InoWorx programming environment, which will default to a new unnamed project. As you can see, the main workspace is created and the main program block is automatically generated. Let's create our target. The target is the InoDrive unit that we will download our program to later in this tutorial. On the front of the drive, find the serial number located here. We will need this serial number to define our target. Back in the InoWorx programmer, click the modules icon under the targets group in the main tree. This will open up the modules dialog. Click the Create New button and enter a valid name. In the IP field, enter the InoDrive serial number and then click Create. If you notice the modules icon in the target tree, it shows a value of 1 indicating that one target has been created. Now we want to create an axis for our drive. Click the axis icon in the tree to open the axis dialog and then click Create New. From the axis dialog, enter a valid name. The select field is populated by a drop-down list of motor and motor mechatronic items that have been pre-defined by Cardinal Kinetic and that are included with InoWorx. For this tutorial, we know that the physical motor unit we have is an Electrocraft wheel unit, so we will select it. Please contact Cardinal Kinetic technical support for more information about the pre-defined axes and properly selecting the right one for your application. Click Create to create the axis. After we create our axis, you can see that the axis icon shows a value of 1 indicating that we have one axis created. Now we want to create a profile for our axis to use when we instruct the motor to run. Click Profiles in the tree and the Profiles dialog opens up. Click Create New and the Profile dialog opens. Enter a valid name. For our tutorial, we are going to use the default profile. The default profile is what is shown in this dialog in the grayed out boxes with all of the custom checkboxes remaining unchecked. Details about these custom settings will be covered in further tutorials and within the InoWorx online documentation. Click Create. Now you will notice that the Profiles icon in the tree shows a value of 1 indicating that we have created one profile. Please note that even though we are using default motor parameters, we still have to create a profile because all motor command blocks require a valid and named profile. Now we are set to create a simple program. The first thing we want to do is configure and initialize our axis. This instruction block is typically placed in the initialization boundary of the main program block. Under the motor instruction header, click and drag the Configure Axis block to the main program's initialization boundary. Click the slot and check Local, indicating that we want to control whatever axis is connected to our physical local InoDrive. Click Axis and select the axis we created. Later, when we download the program, this instruction will tell the InoDrive that our Electrocraft motor is connected to its motor port. The second item we want to place in the main program's initialization boundary is an instruction to enable the motor. From the motor area, click and drag the Set Axis Motor instruction and drag it to the initialization boundary. Select Local for the slot and Enable for the action we want to take. For our tutorial, the functionality we want to program is to utilize one of the digital inputs as a run command. When digital input 0 is on, we want to run the motor, and when digital input 0 is off, we want to stop the motor. To determine whether input 0 is on or off, we need an I/O input block, and then in order to act upon its on or off state, we need an if-then-else logic block. Click the logic instruction header and then click and drag the if block to the main loop boundary. We need to make this an if-then-else instruction, so click the settings icon for the block and drag the else statement from the left side to the right side and attach it to the if statement. Now you can see we have an if true boundary and an else boundary. For the if true portion, we want to check if input 0 is on. We find this by clicking the I/O instruction header and drag the get slot input block and attach it to the if instruction block. Click slot to select our local NO drive. You can click the drop down to select which of the 4 digital inputs you want to examine. In this case, our on-off switch will be wired to digital input 0. The action we want to take when digital input 0 is on will be placed within the if boundary. Click motor and drag the motor command block to the if boundary. Select local for the slot, then select the profile we created, and then select run from the drop down. For the else boundary, we want to tell the motor to stop. In this case, let's copy the previous instruction, drag the copy to the else boundary and change its function from run to stop. Our logic is complete. When digital input 0 is on, we command the motor to run, and when digital input 0 is off, we command the motor to stop. Let's save our program by clicking the save icon and entering a valid name. Now let's connect to our NO drive to download and test our program. With your NO drive connected to your PC's Ethernet port, click the download icon. You can see the status of the download in the output area just below the resources tree. For this tutorial, we have connected a maintained switch to digital input 0. When we turn it on, the motor runs. When we turn it off, the motor stops. This tutorial has shown how to connect a motor and make it run with a simple program. There are many more options and techniques to customize how to run, stop, and accurately position the mechatronics attached to your motors using NO drive and InoWorx. We hope you have enjoyed this tutorial. Please visit us at cardinalkinetic.com for more information.